Hello, welcome to Chapter 5, Section 1, Graphing Polynomial Functions, Day 2 notes. So now we're going to explore a little bit more about polynomial functions, and the first thing we're going to do is try to graph it just given an equation. Now, you've graphed things before, and your tool that you're used to using is a calculator. So for this problem only, we are going to use a calculator. And what we're going to do is we're going to take the equation, we're going to plug it into the calculator, and we're going to see what outputs we get. Now, we want very good points. So you are plotting every single point you possibly can based on the window that you're looking at. Now, if you look at my graph, I've already done this. It does take a little bit of time just to type your equation in the calculator, and then remember to get a table. You press Control and then the letter T, and a table will pop up once you've graphed it. And so you can take that table and just write it down. And you're writing down all of the X values that are in your window. So make sure you're paying attention to the problem. Now, in my window, I have it going from -5 to 5. Yours might not be that, right? Yours might be -10 to 10. Whatever the case may be, though, you're putting down all the points and you're plotting them. And so that's how you pick the points, right? You're picking the ones that are in the window, so you get a good picture of what's going on. You want enough to be able to actually see what's happening. And of course, on your calculator, you can see the entire graph, hopefully. So this is what the graph looks like. You plot your points, you connect your dots. Then this problem asks you to write it in factored form. And so to write something in factored form, you first need to find the zeros. Well, here, x equals -4, -2, and 4. And the reason I know that is because that's where it crosses the x-axis. At -4, -2, and +4. So, -4, -2, +4. Now we're writing factors based on the zeros. So if x equals -4, and I actually want it to be a factor, right? That means I need to take, I'm going backwards now. So instead of taking your factor and setting it equal to 0 like we did in day 1 notes, we're going to find the 0 and turn it into a factor. So to do that, we're going to move the 4 to the other side. So we're going to add 4 to both sides. So it's going to be x plus 4 equals 0, which means that that's one of our factors. We're going to do the same thing for x equals 2, -2, and x equals 4. So if x equals -2, we move the 2 over, it becomes positive, so x plus 2 equals 0. And if we move the 4 over, it becomes x minus 4 equals 0, right? Just the opposite, just like always. Which means that if I were to write this in factored form, we would get x plus 4, x plus 2, x minus 4. Okay, nothing really that super tricky about it. So that's the answer. The next thing we want to do is determine where our function is positive and negative. And this means that if it's positive, it's going to be above the x-axis. So if we look at this graph that we just came up with, it is above the x-axis right here and right here. It's below the x-axis right here and right here. So that would mean it was negative. So it's positive, positive, and then negative here and negative here. Right? Now we can determine this by making what is called a sign chart. So what we're going to do is, to make a sign chart, is go ahead and find the zeros. So if x minus 6 equals 0, then x equals 6. If x minus 2 equals 0, x equals 2. And if x plus 2 equals 0, x equals -2, right? Inside horizontal inverse, we're just finding the zeros. So now we're going to take all those numbers and plot them on a number line. Well, remember, when you plot things, you plot it from left to right. Now, my graph, my sign chart is just to tell me where it's positive and where it's negative. So I want to go ahead and plot them, just those numbers. So -2, 2, and 6. I don't care how accurate it is. All I care about is that it's good representation of what's going on. Then we need to find the numbers inside. So what you do is you follow these steps, right? You find the factors, you plot the zeros, we did that. Then we test points between the zeros by plugging those numbers into the equation to see if the outcome is positive or negative. I do not care what number it is. All I care about is the sign that I get from the equation. That's what matters. So let's plug in a number between -2 and 2, right? So in this area right here. So a number between -2 and 2 would be 0. So if I plug in 0, right, so let's find f of 0. I'm going to go ahead and use the factored form. Then 0 minus 6 is -6. 0 minus 2 is negative 2, but that's squared. 0 plus 2 is 2. Now, what happens here is if I square a negative, that becomes positive. So it's a positive times a positive times a negative. Well, a positive and a positive make that positive, so a negative times a positive is just negative. So that means that this interval right here is going to be negative. You see how I did that? Let's do another one. So let's plug in, let's find something in here. So let's do 3, right? Something relatively small. I don't want it to be super complicated because that means more math that I have to do. And, I know we don't want to do that. So 3 minus 6 would be, and now I'm going to just write the signs, okay, for each one. So 3 minus 6 is negative 3, so that'd be negative. 3 minus 2 is positive, and that's squared. 3 plus 2 is another positive. Okay, so what I'm doing is I'm taking the number, plugging it into the factor, and determining, okay, well, what sign did I get by plugging that in? Well, if I have a positive squared, that's positive. Positive times positive is positive, so this all ends up being positive times a negative, which is still negative. All right, so that means that's going to be below the x-axis as well. Now I need to pick a number that's very, very, very negative. Okay, so I like to pick negative 500. So negative 500, right? Just be really extreme about it, because I've got to pick it in this area right here. So negative 500 minus 6, that's going to be clearly negative. Negative 500 minus 2, again, clearly negative. And negative 500 plus 2, also negative. Now this is squared. So a negative negative makes that positive, so it's actually a negative times a positive times a negative. Well, the negative negative makes it positive, so that is actually positive. So this is going to be a positive. And then last area, right here. All right, so I'm going to pick positive 500, right? Because why not? F of positive 500. I'm just trying to be really extreme about it so you can get the picture of what kind of number it's going to end up being. So positive 500 minus 6, that's positive, right? Because it doesn't do much to it. Positive 500 minus 2, still positive, and that's squared. And then positive 500 plus 2, still positive. So positive times positive is positive, which means that this is positive, which means that it's above the x-axis in the blue area, below the x-axis between negative 2 and 2, below the x-axis between 2 and 6, and above the x-axis beyond 6. Now this is going to be important when we go to graph stuff, okay? So you're going to practice this. Now, what you also need to know is what is called multiplicity. Okay, multiplicity means that a factor has an exponent on it, essentially. Okay, and whatever exponent that is, that's its multiplicity. So for instance, if you look at this in this little box, right, we have f of x equals x minus 2 cubed and x plus 4 squared. Well, x minus 2 is cubed, so the multiplicity is 3, because that's the exponent. For x plus 4 squared, x plus 4 has multiplicity of 2 because there's a 2 on it. Now, this means different things when you're talking about the graphs. When you're looking at a graph, what happens is if the multiplicity is even, like this says right here, then it bounces. So if it has an even power, that means it's going to go to the x-axis and then jump right back off. And I'll show you an example of that. When it's odd, it goes right through the x-axis, so it doesn't stop. Right? So if you look here at this example 3, this right here goes through the x-axis, which means that that is odd. Okay, it has odd multiplicity. That could be 1, 3, 5, 7, 9, etc. If you look here at this 0, right, because the 0 is where it crosses the x-axis, that is even. And the reason we know it's even just by looking at it is because it touches the x-axis and then goes straight back up, right? It doesn't actually go through the x-axis. It just kind of bounces off, and that's why I loosely use the term bounces, right? It's not a technical term. It's just the way we're going to talk about it. So that means that at 2, it has an even multiplicity. So it's going to be, if we look at the factors, right, and we go back to kind of what we did in the first example, we have x. We know that x is going to equal 2. And for the odd one, x is going to equal 5. negative 5, because that's on the left. All right, so if I find the factor here, it's going to be x minus 2 equals 0. So x minus 2 is a factor. And for the x equals negative 5, it's going to be x plus 5 equals 0. So x plus 5 is the other factor. The question is, when I look at these equations, I need to make sure that x minus 2 has even multiplicity, and x plus 5 has odd. So automatically, I can mark out this one and this one, because that had even multiplicity for the x plus 5. Also, really, I'm done, because look right here, right? The x plus 5 is an x plus 5, not an x minus 5. And so that's the key. Now, x minus 2 does have even multiplicity, right? Because that's a 2 right there. And that's how you do that. Now, we're going to take all of these things and put them all together, right? We're going to write a function that would match the graph shown. We know some things, and it would just have to match in some way, shape, or form. Okay, so first, just based on the number of zeros, it touches the x-axis at 1 and then bounces off, right? Which means that one of the zeros is going to be x equals 1. The other one is going to be x equals 5. So I can go ahead and write the factors. So x minus 1 equals 0, x minus 5 equals 0. So we have the factors x minus 1, x minus 5 at least. Okay. Now, it does bounce off of both of them, which means that they both have even multiplicity. Now, it's just saying find an equation that represents this. So it doesn't have to be this exact equation necessarily, okay? But we need all the attributes that would make this true. So since it's even because it bounces, I'm just going to put a 2 on here for both of them. Then what I'm going to do is find the y-intercept and use it to determine the leading coefficient of the function. So I'm going to say, oh, well, I need to find this number that's out front. When really, I don't need to do that, because what do I know about a function that's going down? Because we've talked about this, right? If it's going down, then it's negative, which means that this is going to be a negative equation. And there's your answer. Right? If it had been odd, it would go up. I'm sorry. If it had been positive, it would go up. Now we're going to sketch the graph based on the equation. So we're going to do the opposite, right? The exact opposite thing of what we just did. And it is just a sketch, okay? So it might not be super, super perfect, but it's going to look kind of nice, okay? So the first thing we need to find are the zeros. Remember, to find the zeros, you take your factors, you set them equal to 0, and you solve. So if x squared equals 0, then x equals 0. If x plus 7 equals 0, then x equals negative 7. If 3x plus 9 equals 0, then 3x equals negative 9, and x equals negative 3. So let's go ahead and plot those. So we've got 0, negative 7, and negative 3. All right. Now we need to determine if the function has an even or odd degree and whether it's positive or negative. So here's how we're going to do this. First, it's negative. Okay, we know that automatically because of this right here. Then for the power, we're going to add these up. So it's squared, and then a 1, and then another square. So 2, 3, 4, 5. So it's odd. Well, if it's odd, that means the end behavior, or the ends of the graph are going to go in opposite directions. But because it's odd, it'll either do this or this. Right? It's one or the two. Because it's negative, it goes down first. So it goes down to the right. So it's going to go like this and like that. Finally, we're going to see where it bounces and where it goes straight through. And we actually already have the y-intercept, because if you plug in 0, you get 0. or the point 0, 0 is a given point, right? Because it's a 0. So let's go ahead and see where it bounces. It's going to bounce at 0, and it's only going, and at -3, and it's going to go through at 7. So it's going through, bounce, bounce, and that's kind of what it would look like. Okay, something like that. This is just a sketch. We're just trying our best. And that's what you're doing today.